Good morning, everybody. This is Mission Control Koloyov. Welcome to NASA's live coverage of the launch of the first expedition crew to the International Space Station. On a foggy day in Baikonur, you're looking at a Sojuz rocket ready to deliver U.S. astronaut Bill Shepard and Russian cosmonauts Yuri Gudzenko and Sergei Krikalev to what will be their home for the next 4 months. Soyuz, the Russian word meaning union, is 52 minutes 20 seconds away from launch. Launch is set to occur 52 minutes 47 seconds after the hour. That's 10:53 this morning in Moscow and 12:53 this afternoon local at the Baikonur Cosmodrome in southern Kazakhstan. Baikonur is home to many historic launch pads and is a sprawling complex measuring about 95 by 75 kilometers. Earlier this morning, the crew prepared for the launch with a number of activities associated with pre-launch activities, very similar to what you would see in preparation for a shuttle flight. The crew reported earlier this morning, and one of the traditions is, as we see here, Bill Shepard drawing the outline of what the current makeup of the International Space Station is. The modules in orbit right now, the Unity module provided by the United States, the first module launched by the U.S. Space Shuttle. The most recent module he's drawing right there, the Z-1 truss element, the two Russian modules, the Zarya control module and the Zvezda service module, which will serve as the crew's home for the next 4 months. Then once he was finished drawing the outline, each crew member signed this, and again, this is a routine, a tradition for the crew members. Now joined by Johnson Space Center Director, Mr. George Abbey. This is just before the crew members were set to head over to the suit-up room this morning shortly after wake-up. Crew members were greeted and then presented for the State Commission, the report to the State Commission. Also the traditional blessing before the crew members head over to the suit-up room. And here the crew members are walking out of basically the crew quarters with Bill Shepard, the commander of Expedition 1, along with Yuri Gudzenko and Sergei Krikalev. Yuri Gudzenko will be the Soyuz commander, and Sergei Krikalev will serve as the flight engineer on the mission. Now boarding a bus, the crew members will again head over to the suit-up room.
А можно еще раз сократить? Он даже не знал.
There's a short drive from the crew quarters over to the suit-up area. And again, coming off the bus, Sergei Krikalev, Bill Shepard, Yuri Gudzenko. The final medical checks for the crew members, Bill Shepard here, just before they prepare to start putting on their, basically their launch and entry suits that are pressurized suits to protect the crew members during the climb to orbit today, and also for the return to Earth should that become necessary. Soyuz Commander Yuri Gudzenko now preparing to climb into his suit. This all occurred about 3 hours ago before the crew members headed out to the launch pad. It's a fairly routine or comparable to what the space shuttle crew would do in preparation for heading out to the launch pad for a shuttle launch as well. Crew members a good safe seal on the suits before they head out to the launch pad. Bill Shepard seen here putting on his communications cap. Again in the background, Sojuz Commander Yuri Gudzenko. Bill Shepard, a Navy in the a captain in the Navy, 51 years old. Again, will serve as the commander on this 4-month expedition, first expedition mission to the International Space Station. Yuri Gudzenko, a lieutenant colonel in the Russian Air Force, is 38 years old, and Sergei Krikalev is a 42 years old and will serve as the flight engineer throughout this Expedition 1 mission. The crew of Expedition 1 trained nearly 4 years for this event, and just about ready to go with the final preparations for their suit. And again, once they have their suits on, they'll head over to another part of the room to basically conduct pressure integrity checks on the spacesuits themselves. Vasily Tsibliev and JSC Director Mr. George Abbey, another group of people, Mike Baker, who is the head of NASA's operation here in Moscow, the backup crew, Ken Bauer-Sox, Bajorov and Michael Turin. Thumbs up from the 3 crew members of Expedition 1. Now in their suits, and now this again occurring about 2.5 to 3 hours ago before the crew headed to the launch pad. The final checkup on the suits to ensure pressure integrity of all of the spacesuits. First Bill Shepard, then the Soyuz commander Yuri Gudzenko, and then Sergei Krikalev. Again, the backup crew behind the primary crew, Ken Bauer-Sox, Vladimir Zhurov, and Michael Turin. And now the final activity for the crew members before heading to the pad, the report to the State Commission behind the glass, watching the crew, observing the final report to that State Commission. Again, JSC Director, Mr. George Abbey, General Peter Klimuk, the head of Star City, the Gagarin Cosmonaut Training Center, Michael Foley, Assistant to the Director at the Johnson Space Center for Expedition Operations. And now the crew members heading out for the trip to the launch pad. Sergei Krikalev first, Yuri Gudzenko in the middle, and Bill Shepard on the right of the commander. Now heading to their bus for the trip to the launch pad. Shrouded in both fog and a burn-off from the liquid oxygen that's been loaded aboard the vehicle. At the top now, Sergei Krikalev. We're back at the launch site now. This live view as the protective access stands around the Sojuz being retracted. The Sojuz capsule itself was mated to its booster 3 days ago, and the rocket was transported by rail car out to the launch pad on Sunday. The launch complex known as Site 254. It's actually the very launch pad that has been used for every crewed launch from Baikonur, including that of the first human to be sent into space, Yuri Gagarin, almost 40 years ago. After reaching the pad, the Soyuz rocket was raised vertically for the final preparations for launch. The rocket, with the capsule housed inside a protective shroud at the top, stands 162 feet tall, that's about 49 meters, and weighs 683,400 pounds at liftoff. Once in space, the crew will perform several orbital correction burns using thrusters on the Soyuz to adjust its altitude in relation to that of the International Space Station. It's part of the journey to begin the permanent occupancy of the new facility.
The crew members of the first expedition to the International Space Station view their planned 17-week mission as a shakedown cruise, the opportunity to put all the years of discussion and planning for the permanent habitation of space into action, and to be on hand to respond if any bugs crop up.
This is kind of a test program, and the first thing that you do in a test program is go into some nooks and crannies of the hardware and software that you haven't been able to look at before and make sure that it's functional.
There are many new systems here that have been indeed tested on the ground. They haven't been tested in microgravity, so we do expect that there will be some difficulties. I'm certain that there's not going to be any serious major failures, but there might be some minor problems, failures that will take place that will require taking care of.
First step, complete the setup in Zvezda, the module that provides the crew's living quarters and life support systems, and the station's propulsion and command and control systems.
Then we're going to go around to various systems in service module. We have computers to install, radios to put in, just probably several days to a week's worth of holding things down, wiring things up, and punching buttons to make sure they run right.
After just a few weeks together on orbit, the expedition crew members receive visitors, the first of 3 shuttle crews scheduled to arrive at the station during their tour of duty.
Clearly, each shuttle will bring something that will require it to be installed, and then you have to test it, check it out, check out the new system. In emotional terms, purely. We will be looking forward to our compatriots from Earth who will bring us things from our people who are dear to us. They might bring us some packages. It's going to be very nice to get together with them.
The payload on the first shuttle mission is a major addition to the station's electrical power system, a set of solar arrays spanning more than 200 feet to gather sunlight and convert it to electricity, batteries to store the power, and radiators to diffuse the heat created by operating the station. And new hardware on the station means a new set of duties for the station crew. In this case,
for us it will mean that we have to reconfigure a lot of things to have different power sources, because before for a flight only power available for us would be power generated by FGB and service model solar arrays.
Expedition crew members will also receive new supplies on board Progress cargo vessels launched by the Russians from the Baikonur Cosmodrome in Kazakhstan. For each Progress, the station crew must devote time to unpacking the craft, stowing the contents, and keeping a good inventory of where things are located.
And then once the cargo vehicle is emptied, we will be stowing on board the cargo vehicle our garbage, the food stuff we haven't used up, so and the things that we need to put into have taken away as garbage, all that will be put over on the cargo vehicle.
Near the end of the year, plans call for Gudzenko and Krikalev to climb into a pair of Russian Orlan spacesuits and conduct the crew's first spacewalk inside Zvezda's transfer compartment.
Actually, major task to do is to reconfigure station for docking with new modules. So we need to rearrange docking on the station.
All three crew members are qualified to conduct a spacewalk, and since circumstances could change over the course of a long mission, they're prepared for a wide variety of spacewalk tasks, and for the possibility of a second excursion for other assembly or maintenance tasks being added to their flight plan. The second shuttle to arrive at the station during this increment is due in early 2001, carrying the centerpiece for scientific research on the station, the U.S. laboratory module named Destiny.
5A will deliver lab. It's new model which is going to be a central part of US side of the station. It also has new computer systems, new hardware for future scientific equipment, and life support equipment also. So it would be another big and interesting task for us to activate all of this, check out, to check it in different modes, to reconfigure all computer systems on board of the station, to make computer able to talk to each other and exchange information.
The third shuttle mission, scheduled for about a month after the lab arrives, carries a cargo of size and logistics, including more equipment racks for the lab, in a reusable moving van module named Leonardo. It also arrives with the second expedition crew, Commander Yuri Usichov and astronauts Susan Helms and Jim Voss. And that sets the stage for another first in the International Space Station program.
I think it's very important for the first crew to have a good handover to the follow-on crew that's going to show up, and the process of signing over the station to the next rotating crew, I think, is going to be an important difference in how we operate on station that we haven't really seen before on shuttle.
The station that Shepard, Gudzenko, and Krikalev will leave behind when they climb on board Discovery for the trip home will be ready to provide a home on orbit for the astronauts and cosmonauts from the partner nations, and to begin its scientific mission. But Shepard sees ISS as being even more than that.
It gives us unique access to the space environment where we hope we can do very interesting and productive research, but it really means that we're going to develop a lot of the technology that will allow humans to go elsewhere away from the planet. So if we don't have this progress with this space station, it means that humans in space are pretty much destined to stay close to the Earth, and I don't think that's what humans are about.
Some of the milestones in the final hours of today's countdown have included the activation of the Sojuz's internal systems for final health checks, including the capsule's radio communication system, the thermal control system, and the motion control system to provide stability for the Sojuz in orbit. Just a few minutes ago, the re-entry vehicle hardware testing was completed, and leak checks performed on the spacesuits for the three cosmonauts inside the Sojuz capsule on the top of the Sojuz rocket. Again, inside that capsule, Commander Yuri Gudzenko, Sergei Krikalev to his left, and to his right, U.S. astronaut Bill Shepard serving as the commander for Expedition 1. The crew members again inside just completing the health checks, or basically the leak checks on their suit. About 4.5 hours ago, the 3 stages of the Sojuz rocket were loaded with propellant, about 150 tons of propellant and liquid oxygen, which has been replenished and topped off over the past 2 hours. Among those present in Baikonur awaiting this historic launch is NASA's Rob Navius, who filed this report earlier this morning.
Kyle, for the 3rd time in the last 2 years, an international cadre of VIPs and news media has gathered here on the steppes of Central Asia to watch a new chapter in human spaceflight history unfold. On November 20th, 1998, the International Space Station was born with the launch of the first component, the Zarya control module. A little over 3 months ago, the Zvezda living quarters was launched here at the Baikonur Cosmodrome, setting the stage for today. In less than an hour, the first permanent residents of the station will be launched from this once secret launch complex, which lies due north of the railway junction town of Kiratam, east of the Aral Sea. Work on this cosmodrome began 45 years ago in 1955, when the Soviet military required that test facilities be constructed to accommodate ballistic missile testing far away from U.S. Air Force surveillance posts in Turkey. The man who led that ballistic missile testing became the chief designer of the Russian space program, Sergei Korolyov, whose name honors the town housing the Russian Mission Control Center outside Moscow. Within 2 years, the site, which had begun as an outpost of tents, shacks, and caravans of gypsies, had blossomed into a huge spaceport equipped with launch pads, assembly buildings, and technical laboratories. Soon afterward, a system of roads and railways took shape, creating an enormous complex unrivaled in the world. Through the passage of time, missiles at Baikonur yielded to manned and unmanned spacecraft, and on April 12, 1961, 20 years to the day before the first space shuttle launch, a human first left the planet from here to begin the exploration of space. Now, almost 40 years later, international cooperation takes on a new milestone with the launch of Bill Shepard, Yuri Gudzenko, and Sergei Krikalev, possibly the last time in our generation that space will not be inhabited. Today, with NASA and other agency officials on hand and International Space Station officials here as well, the stage is set on a cold, windy, foggy day for the culmination of years of effort to send the first residents of this international facility on their way for their historic docking on Thursday. That's it from the Baikonur Cosmodrome here in Kazakhstan, Kyle. Back to you in Korolyov.
The crew was loaded aboard the Sojuz about 8:15 this morning Moscow time. That's about a little more than 2 hours ago. They climbed inside a hatch on the side of the capsule. There are 2 cameras inside that capsule, one looking directly toward the commander of the Sojuz itself, that's Yuri Gudzenko, and then the view that we just saw was a view of Expedition 1 Commander Bill Shepard, who is serving as the commander for the entire expedition. Shepard, 51 years old, was named to lead this first crew to live aboard the station back in January of 1996. He'll be responsible for the overall safety and success of the crew's planned stay on orbit. This will be his 4th trip into space, having previously flown on 3 shuttle missions. From March 1993 until his assignment to this crew, Shepard served as the Deputy Space Station Program Manager in charge of the redesign of the entire project. He will be in charge of the outfitting of both the U.S. and Russian modules comprising the International Space Station during this phase of flight, and the activation of station hardware, which will be delivered to the ISS during 3 visiting shuttle assembly missions. Shepard will have primary responsibility for the systems in the U.S. laboratory Destiny once it is attached to the station in January of 2001. Next to him, just out of view, is the commander of the mission, Yuri Gudzenko, a lieutenant colonel in the Russian Air Force, 38 years old. He was named to the crew shortly after Shepard and Krikalev were named. He was named and added to the crew in 1997. He commanded a mission to the Mir space station during a 179-day mission in 1995 and 1996, which actually saw a shuttle crew deliver the docking module to the Russian Mir space station. Gudzenko on this flight will be responsible for all of the systems of the Soyuz capsule itself, from launch through docking to the station, and he would, of course, be responsible for guiding the Soyuz capsule to a landing should it be needed as an emergency vehicle to return the crew home in the event of a problem on orbit. Gudzenko will join his crewmate Sergei Krikalev for the one planned spacewalk. Of course, right now that's not in the timeline, but if there was a spacewalk, he and Krikalev would conduct that spacewalk during their stay on orbit. The three stages of the Soyuz are all liquid-fueled with kerosene as their propellant. The first stage has 4 liquid rocket engines strapped to the side of the core vehicle. Each has a single engine with 4 main chambers and 2 gimbaled vernier thrusters providing 3-axis flight control. Combined with the core engines, these 4 strap-on boosters will burn for approximately 1 minute 58 seconds. The core engines serve as the second stage and continue to burn until about the 4 minute 58 second point. The core vehicle is powered by a single engine with 4 vernier thrusters, again providing 3-axis flight control after the first stage boosters have separated. The third stage has a single engine that will burn for about 4 minutes, 2 seconds, shutting down at about the 9-minute mark after launch. Once the final stage has completed its job, the Soyuz spacecraft will be in an initial orbit of 141 miles at its high point and 112 miles at its low point. That's 227 by 180 kilometers. Additional engine firings will occur over the course of the next 2 days to place the Soyuz at an altitude closely matching that of the International Space Station. The 23.5-foot-long Sojuz TM spacecraft weighs 15,600 pounds and is composed of 3 modules. At the top, the orbital module, at the bottom, the instrumentation propulsion module, and sandwiched between the descent module in which the crew resides. The spacecraft has a solar array wingspan of nearly 35 feet. The entire spacecraft is protected at the top of the rocket by a shroud that is jettisoned about 3 minutes after launch. The orbital module, also known as the habitation module, is used by the crew during orbital operations. The section includes the docking mechanism, hatch, and rendezvous antenna. This portion of the Soyuz separates from the remaining compartments only after the deorbit burn has been completed. It burns up harmlessly in the Earth's atmosphere. The descent module contains 3 personally contoured couches for the crew members during launch, re-entry, and landing. This module contains all the controls and displays necessary for critical flight activities. It also contains life support provisions, batteries for the re-entry and landing, as well as the parachutes and landing rocket engines. The instrumentation propulsion module actually is made up of 3 smaller compartments: intermediate, instrumentation, and propulsion. The intermediate compartment basically provides the structural attachment to the crew compartment. It houses the oxygen storage tanks, attitude control thrusters, avionics, and communications and control equipment. The instrumentation compartment houses all avionics equipment used for primary guidance, navigation, control, and computer systems for the entire spacecraft. It is a sealed pressure vessel containing nitrogen gas used to circulate and cool all of the equipment. The propulsion compartment performs all orbital maneuvers, including those needed for rendezvous with the International Space Station and the deorbit burn at the end of the spacecraft's mission. Its propellants are nitrogen tetroxide and unsymmetric dimethylhydrazine, which also fuel the reaction control system that provides attitude control throughout the orbital phase of flight. 2 solar arrays linked to rechargeable batteries are launched folded against the body of the Soyuz. A number of antennae and other sensors are located on the exterior of the instrumentation propulsion module and on the solar arrays themselves. This compartment separates from the descent module after the deorbit burn and burns up harmlessly in the Earth's atmosphere just like the orbital module. The capsule not only will serve as a crew transport vehicle to and from the International Space Station, but it also will remain docked to the station and act as an emergency return vehicle in the event the crew should have to leave the station unexpectedly. About 40 minutes ago, updates to the Soyuz's onboard computers were sent in pre-programmed commands, and just about 20 minutes ago, launch officials initiated a timing device governing the final major events leading to the Soyuz's launch, 23 minutes, 20 seconds from now. The launch time officially 10:53 this morning Moscow time, 12:53 p.m. Baikonur time. The Soyuz rocket is manufactured in the Russian town of Samara, while the Soyuz capsule is built and tested at Rocket Space Corporation Energia facilities near the Russian Mission Control Center here in Korolyov. This type of launch vehicle is a versatile one which has been used in various configurations to launch satellites since 1963. Its first use as a crew transport was in 1967.
For the crew members of the first expedition to the International Space Station, the voyage to their new home on orbit begins at the Baikonur Cosmodrome in the Southwest Asian nation of Kazakhstan, from the same launch pad where Yuri Gagarin became the first human being to leave Earth for space almost 40 years ago. The first 2 days of their 4-month mission are spent inside a Russian Sojuz spacecraft, which also serves as the means for a quick return to Earth in case of an emergency aboard the station. The trip to the station is designed to last 2 days in order to make more efficient use of propellant.
And also, there are some different opinions on advantages to fly a little longer to the station because people get accustomed to space conditions a little more, and because docking with the station is a very critical task. It's better to be more or less adjusted to space flight environment.
During that time, the 3 men who comprise this crew will have the run of one of Russia's most dependable spaceships, with a habitable volume of a little more than 300 cubic feet in a 2-part crew cabin.
One is relatively small, actually very small, for 3 people to fly up and down, and it's very well protected. It's designed to sustain high G and very high temperatures for re-entry.
The other is a small habitation module originally designed as a prototype space station. The vast majority of flight operations on the Soyuz are automated. However, veteran Soyuz commander Yuri Gitzenko is in overall charge of the ship and responsible for any hands-on flying tasks. The flight engineer is the jack of all trades.
Flight engineer is responsible for all systems on board the station, and we usually make jokes saying that we're responsible for all systems, including crew, because it's one of the systems which control spacecraft.
Well, my main job on NASA, it's kind of funny, as the expedition commander, it's kind of interesting. I try and stay out of the way. We're in a very cramped capsule. I run the radios and some of the life support equipment in the Sojuz.
For 2 days, the Soyuz carries the crew closer and closer to the International Space Station. One orbit before docking, the 3 men climb into their Sokol suits, or launch and entry suits. With the Kurs rendezvous and docking system engaged, the Soyuz commander and flight engineer work closely with the team of specialists at the Russian Mission Control Center in Koryolov, near Moscow.
After 2 days, on orbit 32, we'll begin the process itself of docking. First you have the from a distance approach, then we approach the station, then we have the docking itself. As a rule, this is all done automatically, on an automated route mode,
which over 3 orbits of the Earth brings Soyuz together with the station. There's a redundant system which relies on the expertise of the well-flown cosmonaut crew.
But if something happened, it's my responsibility to recognize that something goes wrong, and pilot need to take control. So switch from automated mode to manual mode.
Specifically, I have 2 levers that would allow me to control the vehicle, to do the approach and docking manually. Then following the docking, we check the seal, equalizing pressure, between the transport vehicle and the ISS, we open the hatches, and we start working on the station.
Probably everything will start from light. We need to switch lights on, and for this purpose, electrical power system have to be activated. We need to install a communication link with the ground, so we need to activate COM, and we may need to do some assembly before we use communication system.
Then we're going to go around the house and turn the utilities on. We want to get at the fresh water, be able to heat it and make food, turn the toilet on. It's got some assembly that goes with it. Configure some radios, and if we get all that done the first day, we'll count it as a success.
Leaving them roughly 119 days more to go as they kick off permanent human habitation of the International Space Station.
Back at the launch site at the Baikonur Cosmodrome, the Sojuz stands ready for launch as near continuous checks are being made of all of its systems. The launch countdown stands at 17 minutes, 50 seconds and counting. Liftoff is set to occur 52 minutes, 47 seconds after the hour. Launch is precisely timed so that the crew can rendezvous and dock with the International Space Station 2 days from now. Officials have conducted additional checks of the Sojuz's onboard batteries, having just completed a realignment of the rocket's trajectory control system. In a few minutes, the Sojuz's telemetry systems will be activated and monitoring of the Sojuz's thermal systems begins. 10 minutes prior to launch, the Sojuz's steering jets will be activated as well. Throughout the course of today's climb to orbit, tracking and telemetry is provided through systems in the second and third stages. These two stages have their own radar transponders for ground tracking via individual telemetry transmitters. Vehicle health status is downlinked to ground stations along the flight path and is routed to the Mission Control Center here in Korolyov. Partial real-time data processing and plotting is performed for flight following and initial performance assessment. All of the flight data is analyzed and documented within a few hours after the launch. Here in the Russian Mission Control Center, flight controllers are ready to begin monitoring the Sojuz following its launch and insertion into orbit. At present, Energia conducts oversight of the Russian segments of the International Space Station in this early stage of construction, along with U.S. flight controllers that make up the Houston Support Group here in Moscow, and flight controllers in NASA's Mission Control Center back in Houston, Texas. Standing by in the International Space Station Flight Control Room at NASA's Johnson Space Center is a team of flight controllers watching over today's activities. James Hartsfield is there with an update from the Mission Control Center half a world away in Houston. Good morning, James.
Good morning, Kyle. Here in the International Space Station Flight Control Room in the Mission Control Center in Houston, a team of about a dozen flight controllers is watching over the 81-ton orbiting station in conjunction with their counterparts in Moscow. At present, the station is above the southern Atlantic Ocean at an altitude of about 240 statute miles. When Commander Shepard and crew lift off, the station will be about 240 statute miles above northern Africa near the border of Chad and the Sudan. As the two spacecraft circle the Earth every 90 minutes over the next 2 days, the Sojuz will close over 22,000 statute miles to rendezvous and dock with the International Space Station. A few days ago, the U.S. and Russian control teams performed a dress rehearsal of the upcoming docking by the crew, sending commands up to the station to thoroughly test the procedures and systems required. The station's orientation was altered to match what will be required for the docking in a couple of days, and the entire test went smoothly. The station is in good shape with no problems of concern for controllers. The mood here in the station flight control room is one of excitement as this team awaits the start of a new era in human spaceflight, a moment that they have looked forward to with great anticipation with each new addition to the station over the last couple of years. Overseeing activities here in the International Space Station control room is ISS Flight Director John Curry. Although no communications directly from this team to the crew are anticipated until after the docking and the U.S. Early Communications System is activated, also on duty here is spacecraft communicator or CAPCOM astronaut Sandy Magnus, with astronaut Stephanie Wilson also assisting as CAPCOM. With an on-time launch of the crew tonight, tomorrow this team will watch as controllers this evening, Houston time, controllers here will watch as controllers in Moscow command the undocking of the attached Progress cargo craft. That planned to occur about 10:02 p.m. Central Standard Time today. The Progress's departure will clear the way for the arrival of the crew, which docks at the same aft port of the Zvezda Living Quarters module. At launch minus 13 minutes, 57 seconds and counting, this is the International Space Station Flight Control Room in Houston. Back to you, Kyle, in Korolev.
Thanks, James. For Russian and American flight controllers, the next 2 days will be spent watching over the rendezvous of the Sojuz with the International Space Station, leading to the docking scheduled for 12:24 p.m. Moscow time on November 2nd. That docking, followed about 90 minutes later by the opening of hatches into the station, marks the starting point of continuous human presence of this space station. The countdown is proceeding on schedule for the launch of the Sojuz, now just 13 minutes, 15 seconds away. Ground controllers at Baikonur are sending commands to activate the telemetry system, which will relay vibration and acoustic data to the American and Russian flight control teams here in Korolyov during the Sojuz's ascent. The crew on board, again, has been on board for about 2.5 hours now, conducting final systems checks, leak checks with their spacesuits, and also communications with the Russian flight controllers. We've heard some music that has traditionally been played to the crew. It's an experienced crew led by a veteran NASA astronaut teamed with 2 Russian cosmonauts, bearing almost 2 years' worth of time on orbit.
The first people to call the International Space Station home are 3 veteran space travelers representing the 2 most experienced spacefaring nations in the world. The commander of this first expedition, U.S. Navy Captain Bill Shepard, grew up with a love of being around the water. He says his plans for a career in the Navy were strongly influenced by his father, who was a Navy flyer during World War II.
I went through college, I went to the Naval Academy, and I wanted to be a pilot, but unfortunately could not pass my eye exam, so I became a diver. And I always thought, kind of in the back of my mind, there was a lot of correlation between being in a spacesuit and some of the activities that you do when you're diving. But until about 1978, when the shuttle program really got going, I didn't really think about it.
Shepard was selected as an astronaut in 1984 and made his first flight as a mission specialist in December 1988. He flew twice more, in 1990 and 1992, for a total of almost 19 days on orbit. He's been assigned to the International Space Station program since 1993, deeply involved in the overall redesign of the complex, and was deputy program manager at the time he was named to command this crew. Sojuz commander Yuri Gidzenko says he began dreaming of being a pilot as a small boy, and since his own father was in the military, he dreamed of becoming a military pilot.
When I graduated from high school, I entered high military pilot school, and after that I flew as a military pilot in Soviet Union Air Force. And after that, some manager from Gagarin Training Space Center suggested me to pass technical medical exam to be a cosmonaut, and I agreed. And after that, I was selected in a cosmonaut team.
In 1994, Gidzenko trained as commander of the backup crew for the Euromir 94 mission. The next year, he made his first trip to space as commander of the Mir 20 crew. During that 6-month flight, an international astronaut crew on Space Shuttle Atlantis delivered a docking module to the Russian station. Since beginning his training for this mission in 1997, Gidzenko says he's enjoyed traveling the world and meeting the people involved in the ISS, even though the travel has meant time away from his home in Star City and from his wife and 2 sons. The most experienced member of this crew is flight engineer Sergei Krikalev. He also grew up dreaming of being a pilot, and maybe someday a cosmonaut. After high school, he moved on to the hometown Leningrad Mechanical Institute, where he received a degree in mechanical engineering.
When I graduated institute, I had chance to select where I'm going to work, and I asked to assign me to work at Energy, although it need moving from my hometown, leave my friends and parents back in St. Petersburg and travel to place where I have no relatives, no friends, no one I know. So still I decided to do it because it was new adventure, and in 1980 I came to Korolev city now to start to work at Energy.
During those years, Krikalev was a member of the National Aerobatic Flying Team, winning Champion of Moscow in 1983 and Champion of the Soviet Union in 1986, the year after he was selected by Energia to train as a cosmonaut. After completing the basic training, Krikalev launched to the Mir station for the first time in late 1988. He began his second mission in mid-1991 and later agreed to stay on board Mir as flight engineer with the next crew in order to accommodate a change in mission scheduling. He took part in 7 spacewalks during what ultimately was 10 straight months in space. Later in 1992, after the Russians signed a cooperation agreement with NASA, Krikalev came to the Johnson Space Center to train in the American system. In February 1994, he became the first cosmonaut to ever fly on a space shuttle mission. He completed his second shuttle flight in December of 1998 as a mission specialist on the first International Space Station assembly flight, when he was asked for his first impression of the new station.
Looks like home. What do you think?
Slow yet. We need to add more modules.
With this mission, Krikalev becomes the first person ever to make a second visit to ISS. Altogether, these three men bring more than 680 days, a year and 10 months experience on orbit over 8 space flights, to this 4-month mission that begins the permanent human habitation of the International Space Station.
Welcome to those just joining NASA Television's live coverage of the launch of the first expedition crew atop a Sojuz rocket from the Baikonur Cosmodrome in Kazakhstan. Engineers continue to monitor all systems aboard the Sojuz rocket and its Sojuz capsule, set to begin its voyage to space just 6 minutes, 45 seconds from now. The official launch time, 10:53 this morning Moscow time, 12:53 local in Baikonur, or 52 minutes, 47 seconds after the hour. Inside the capsule, the crew members now have established ventilation through their pressure suits, and they've also closed their visors for launch. Now approaching 6 minutes, 25 seconds to launch. A few minutes ago, commands were sent to switch power from ground sources to the Sojuz's onboard batteries. Soon after the Sojuz reaches orbit, its command and control system will be activated, and stored computer commands will deploy the communications antenna on the spacecraft itself. The first will be the Coors rendezvous and docking antenna, which will be used to provide automatic range rate information to the Zarya control module, which is the first element that was launched to the International Space Station. A little more than 9 minutes after launch, the Soyuz's solar arrays will be deployed, stretching to a wingspan of about 35 feet or 10 meters. They will collect solar power for use by the batteries to generate electricity for equipment on board. About 90 minutes into the flight, the crew aboard the Soyuz will continue its programmed activation sequence as it makes its first pass over Russian ground stations. Systems activation will begin in rapid succession, including the module's power supply system, its radio communication system, and of course the critical motion control system. Coming up on 5 minutes and counting to the launch of the Expedition 1 crew. At this time, all of the launch complex and vehicle systems are ready for launch. On board, the crew members have now activated recording equipment, and the onboard systems have now been switched to onboard control. 4 minutes, 30 seconds to launch. Inside the capsule, Commander Yuri Gudzenko of the Soyuz commander, off to his left is Flight Engineer Sergei Krikalev. Out of view to his right, Expedition 1 Commander Bill Shepard. There are 2 cameras inside the capsule, one looking in this direction, another looking directly toward Bill Shepard. And during the climb to orbit, it's typical to see the inside camera view of the crew members all the way through the ascent phase. Now approaching 3 minutes, 35 seconds and counting.
Everything on board is nominal.
The reports are, again, everything is nominal as the countdown continues, approaching 3 minutes, 20 seconds and counting. On board, the combustion chambers of the side, the attached boosters, and the central engine pods of the first stage and second stage have been purged with nitrogen.
3 minutes to launch. 3 minutes.
minutes and counting.
Pressurization. Copy.
Two minutes and 30 seconds. We're now getting confirmation that the booster's propellant tanks are in the process of being pressurized for flight. Launch minus 2 minutes and counting. All systems go for launch. One minute, 30 seconds and counting.
All right, just go back.
T-minus 1 minute and counting. At this time, the onboard systems, the vehicle is on its own internal power. The automatic sequencer is being commanded, and very shortly the first umbilical tower will be separated from the space, from the rocket.
Ground Sojuz, we copy.
T-minus 30 seconds. Now 30 seconds away from the launch of the first expedition crew to the International Space Station.
Launch. Onboard power. Ignition.
T-minus 10 seconds. 9, 8, 7, 6. We have engine start. 4, 3, 2, 1.
Intermediate.
We have ignition and liftoff. Liftoff of the Sojuz rocket, beginning the first expedition to the International Space Station and setting the stage for permanent human presence in space. We have reports of a good roll and pitch program.
We copy you. Everything on board is nominal.
Sojuz heading toward a link-up with the International Space Station 2 days from now.
40. Launch vehicle is
40
normal.
seconds. Good first stage performance.
Acceleration decreasing. Roll pitch yaw normal.
55 seconds. Reports of the roll, pitch, and yaw are normal. 1 minute into the flight.
60. Roll pitch yaw normal. Vibration is increasing. We do not feel vibration at yaw and pitch. So
1 minute, 30 seconds into the flight, all will continue to go smoothly. All reported normal. Sojuz Commander Yuri Gutsenko, Flight Engineer Sergei Krikalev. Just out of view, Expedition 1 Commander Bill Shepard.
Normal.
Standing by for a report of separation of the 4 strap-on boosters
Pitch your roll normal. 120.
We do have confirmation of first stage separation. The 4 strap-on boosters have fallen away from the vehicle at 2 minutes, 20 seconds into the flight. At this point, the Sojuz is traveling about 1,500 meters per second.
140, the structure parameters are normal. 150, the second stage.
Reports that the second stage engine is performing as expected, 2 minutes, 45 seconds into the flight.
160, control system nominal.
Approaching 3 minutes into the flight, report that the protective shroud on the Sojuz has jettisoned, as has the escape rocket on the top of the capsule.
180, stabilization.
The vehicle is now traveling at a speed of about 4,700 miles per hour.
190, launch vehicle parameters are nominal. 200.
Expedition 1 Commander Bill Shepard. This view sitting just to the right of Sojuz Commander Yuri Gudzenko.
Everything is nominal on board. 210. Launch vehicle control parameters are normal.
3 minutes, 50 seconds into the flight, all continuing to go smoothly. No reports at all of any problems.
230, vehicle stabilization. Normal, copy. 240, second stage engines are operating in stable mode, copy. 250. Pitch your roll are nominal. 260, launch vehicle parameters are nominal.
4 minutes, 30 seconds into the flight, again all going smoothly. The second stage will burn for another 20 seconds or so, and we'll report on the second stage burnout and separation.
Launch vehicle control systems are nominal. Acceleration is increasing. Second stage separation.
4 minutes, 55 seconds, confirmation of second stage separation.
Separation complete. Vehicle stabilization stable.
All continuing to go well with this morning's climb to orbit, the delivery of the Expedition 1 crew to a rendezvous with the International Space Station on November 2nd.
320, launch vehicle parameters are nominal. Copy. 330, engines are
5 minutes, 45 seconds since launch, all continuing to go smoothly inside the capsule. Soyuz Commander Yuri Gudzenko and Sergei Krikalev, along with Expedition 1 Commander Bill Shepard.
350, nominal flight.
About 3 minutes remaining in powered flight now on the third stage engine.
360, pitch your roll nominal. 370, launch vehicle parameters nominal. 380.
6 minutes, 30 seconds, all continuing to go smoothly with the climb to orbit for the Soyuz and the Expedition 1 crew.
Confirmed. .400, vehicle stabilization stable. 410, flight is nominal.
Approaching 7 minutes into the flight. All continue to go smoothly. No reports of any problems whatsoever.
420. Pitch your roll nominal. 430. Third stage engines are operating in a stable mode. 440. Vehicle stabilization stable.
7 minutes, 30 seconds. Another 1.5 minutes or so of powered flight.
150. Flight is nominal. Copy. Situation on board is nominal. 460 launch vehicle structure parameters are nominal.
Approaching 8 minutes into the flight, the third stage engine fires for a total of about 240 seconds, and it actually will cut off when the calculated velocity increment is reached. That would be orbital velocity. After cutoff and separation, the third stage actually performs an avoidance maneuver by opening an outgassing valve in its liquid oxygen tank.
490.
8 minutes, 20 seconds into the flight, another 40 seconds or so of powered flight, all continuing to go very smoothly with the climb to orbit and the delivery of the Expedition 1 crew on the course for a rendezvous with the International Space Station 2 days from now.
The situation on board is nominal, ready for separation.
8 minutes, 40 seconds. We're standing by for burnout of the third stage, separation of the Sojuz spacecraft from that third stage.
Stand by. Charlie. Hold it, Charlie.
9 minutes into the flight. We have confirmation of burnout of the third stage and separation. The crew now on orbit and beginning through post-insertion timeline of activities. Bill Shepard is out of view. In this view, Yuri Gudzenko, Sergei Krikalev.
Бурана, ответьте, слухаю.
Burana, this is MCC.
Бурана, ответьте, слухаю.
Burana, this is MCC.
Бурана, ответьте, слухаю.
Burana, this is Mission Control. How do you copy MCC?
Отвечай, Бурана, слышим хорошо вас.
Burana, we copy you well. You have performed splendidly at the first stage of the flight. Thank you. We're waiting for the command. Flight control switches to Kaliningrad. Mission Control.
10 minutes, 45 seconds into the flight control of the Soyuz now being switched from Baikonur to the Mission Control Center here in Korolyov. The remainder of the crew's trip to the International Space Station now under control of the flight control team here in the Mission Control Center in Korolyov outside Moscow. A successful, clean climb to orbit this morning, just 11 minutes ago. Liftoff occurred on time, 52 minutes, 47 seconds after the hour. Now the pre-programmed and the crew-activated systems on board will be conducted. The crew's testing some of the views that will be used upon its approach and docking with the International Space Station to ensure the proper operation of some of their onboard systems. The launch pad at Baikonur, from which the Soyuz rocket and the Expedition 1 crew departed just 12 minutes ago. Crew now safely on orbit inside protective Sojuz capsule, and 2 additional rendezvous maneuvers will be conducted today for the crew members before wrapping up the day. The first of the series of rendezvous burns scheduled for 2:27 this afternoon in Moscow. That's about 5:27 in the morning Central Time. A third rendezvous burn, if you count the launch today, that rendezvous burn scheduled at 3:08 or 3:09 p.m. Moscow time. That's just a little bit after 6 o'clock in the morning Central Time. Additional rendezvous burn for the crew members scheduled for tomorrow just before noon Moscow time, about 3 a.m. Houston time, Central Time. All of that leading toward a link-up in space with the International Space Station that will take place high above the Asian continent within the Russian ground stations. That docking will, of course, bring the first permanent inhabitants of the station to their home, which will serve as their outpost, their home for the next 4 months.
How do you feel?
Ура, на 30 секунд.
Ура, на 30 секунд.
Ура, на 30 секунд. Принимаем вас хорошо.
How do you copy us on the backup transmitter? We copy you well. We're waiting for your report on the parameters of the descent module, the habitation module.
Принимаю вас хорошо.
Mission control, how do you...
Рано, как ваша подсылка? Рано, я подсылка.
This is Mission Control Koryoff. We're continuing to follow along with the crew in the post-insertion activities now, just 15 minutes since launch.
Принято.
Ира, так быстро не говори. Ты скажи, ты следуешь нас или нет?
The launch pad at the Baikonur Cosmodrome, 16 minutes since the Soyuz was launched, all went very smoothly. The crew has been basically giving an update on systems status. Again, all going very smoothly. The communications a little bit sparse, but as the launch took place 52 minutes 47 seconds after the hour, all continue to go very smoothly. No reports of any issues whatsoever. And as soon as we have confirmation of the deployment of the solar arrays and the communications antenna on board, we'll pass that along either from here in Koryoff or from the Mission Control Center in Houston, which is also flight following the path of the Soyuz spacecraft on its way to a link-up with the International Space Station. So we'll continue coverage on and off from either here or again from the Mission Control Center in Houston. We do have a post-launch news conference that will take place from the Mission Control Center here, scheduled for about 90 minutes or so after launch, but that obviously is dictated by the availability of our Russian flight director colleagues as they continue to monitor now all of the systems aboard the Sojuz from the Mission Control Center here in Korolyov. That handover from the launch site to the control center occurring about 10.5 minutes or so after launch. Again, all went very smoothly. We'll wrap up coverage from the Mission Control Center in Korolyov after this morning's climb to orbit of the Expedition 1 crew on its way to begin the permanent human presence of space on the International Space Station. 17 minutes, 40 seconds since launch. This is Mission Control, Korolyov.
This is Mission Control, Houston. Coming up next on NASA television is a replay of the Expedition 1 launch from the Baikonur Cosmodrome in Kazakhstan. That replay coming up about 2:25 a.m. Central Time. Just about 3 minutes from now. Again, that a replay of today's launch of the Expedition 1 crew aboard a Sojuz rocket from the Baikonur Cosmodrome in Kazakhstan. That launch occurring right on schedule, a flawless climb to orbit for the crew at 1:53 a.m. Central Time this morning.
Bob Cabana, Deputy ISS Manager for International Operations. Bob, this has been such a long time.
This is Mission Control Houston as we watch television of a press conference underway at the Mission Control Center in Korolev outside Moscow. We're currently working audio difficulties to receive the audio of that press conference. Currently working on those difficulties at the moment. Participating in the press conference are Russian Flight Director Vladimir Solovyev, who oversaw activities in Korolev today during the launch of the Sojuz, NASA Flight Director Rick Lebrode, who was at the control center in Korolev as well for the launch, and Director of the European Space Agency International Space Station Program, George Fustel-Buchel. Again, currently we're working on audio difficulties to solve those as we receive video of that press conference underway in Moscow. As we watch and work those audio difficulties, Russian flight controllers have reported to Mission Control Houston that the Soyuz is in excellent shape with all the appendages deployed as planned, a flawless climb to orbit, currently in orbit of about 118 statute miles by 150 statute miles.
Not for America, not for Russia, but
is Mission Control Houston, the International Space Station Flight Control Room here in Mission Control. We're currently... We'll be rejoining the press conference in Moscow shortly. We've been working audio difficulties with that press conference. We are momentarily away from rejoining it, however.
And one Russian crew member on the second crew and 2 American crew members in the second crew. Where is your question coming from? Not quite like that. If there is 1 American, then there are 2 Russians, then the American is the commander. Then if there are 2 Americans and 1 Russian, then the Russian is the commander, and that's the way the 6 crews have been selected. There is an international document and there is an internal document in Russia signed by Koptev, and I'm prepared to take this discussion offline with you. I don't understand the problem, and I don't see a problem. If there are any further questions, please approach the microphones. We're also broadcasting to the United States, so if you have questions, come up to the microphone so that they could hear you in the States. Could you please repeat the question? I don't completely understand. The radio communications between the mission control and the station. What is the language? As per the memorandum, English is the primary language, but Russian is the backup language when we are over the Russian ground sites. Both the languages are sort of equal, with English being the primary language. I suggest that we give the floor to a U.S. flight director in the event that there are questions for him, and then we can go on and recognize the ESA representative. Rick Lebrode, I would like to recognize again.
I see a tremendous amount of excitement in and around this center.
Мы видим большое внимание в центре управления полетами.
This is very understandable.
Это вполне понятно.
Today is probably the most significant event in manned spaceflight.
Можно сказать, что сегодня произошел наиболее значимый момент в истории пилотируемых полетов.
Since the launch of Yuri Gagarin nearly 40 years ago.
Можно сказать, что это самый знаменательный момент после запуска первого человека в космос Юрия Гагарина почти 40 лет тому назад.
Or today will mark the last day, barring any unforeseen circumstances, that we will not have human presence in space.
И сегодня мы будем отмечать, если, конечно, не произойдет никаких, ну, скажем, значительных событий, сегодня будет последний день, когда не будет человека в космосе.
There's been many hours of hard work by many people, both here in Russia and back in the U.S.
Этому предшествовала огромная работа, которая выполнялась как в России, так и в США.
That has brought us to this point.
И эта работа привела нас к этому знаменательному моменту.
This began back with the Phase 1 program back in 1995, early 1995.
Это все началось во время первой фазы нашей работы в 1995 году.
Leading up to this point in history.
И это привело нас к этому моменту в истории.
It's through this time that we foundation.
И за это время мы построили фундамент нашей работы.
That has allowed us to succeed with such a phenomenal event.
И это привело к нам реализацию такого феноменального успеха события.
However, those of us who work on this endeavor realize.
Ну и все, кто занят в этой работе, прекрасно понимают, что
that the work is really just beginning.
Что работа только-только началась.
We have worked and built plans and procedures and processes.
До этого мы разработали планы, писали бордокументацию, намечали
инструкции.
But understand that as we gain more experience, we will continuously be updating these.
Но мы понимали, что по мере накопления опыта мы будем вносить коррективы в эти планы.
It's very satisfying for me to see that this joint partnership between the U.S. and Russia
Я глубоко удовлетворен, что сотрудничество между США и Россией
has allowed us to take this first step
позволило нам сделать этот первый шаг
towards really expanding our horizons,
шаг, который расширяет наши горизонты
and hopefully improving the quality of life on Earth for all of mankind.
И мы надеемся, что эта работа улучшит нашу жизнь и жизнь людей на Земле.
Thank you.
Спасибо. Вопросы есть?
Any questions for U.S. Flight Director?
Да, пожалуйста.
Go ahead. Both for the NASA representative and the ESA representative. In the course of the preparations for this flight, were members of the various organizations involved directly in the interdepartmental and international bodies?
But I cannot answer that question. I know that we have representation at Baikonur.
Я должен извиниться, я не могу ответить на этот вопрос, но я могу точно сказать, что у нас есть представители на Байконуре.
As far as their representation at this committee, I'm not aware of.
Но то, что касается их участия в межгосударственной комиссии, тут мы ничего не можем сказать.
Yeah, I know. From the European Space Agency point of view, I just would like to mention that we have our observers in Baikonur, but we have not actively participated in the State Commission.
То, что касается Европейского космического агентства, я хочу сказать, что у нас есть наблюдатели на Байконуре, но они не принимали непосредственного участия. Пожалуйста, еще вопрос.
Any further questions?
Можно вам предоставить слово?
Then I would like to recognize the representative from ESA, Festel Buchel.
It was a great pleasure for us to witness together with you this launch of the expedition #1 crew here today in Korolev.
Надо сказать, что мы испытали огромное наслаждение, наблюдая старт первой основной экспедиции с Байконура.
A moment where many people in all our countries have been working for 10 or even 20 years.
Но это явилось результатом работы за последние 20 лет части всех стран, которые были вовлечены в эту программу.
And it's a great pleasure for me to congratulate our partners in Russia and the United States for this great achievement having been done today.
Я бы с удовольствием хотел бы поздравить представителей США и России с этим замечательным успехом.
This was the 9th launch to the International Space Station, so you see that the things are already going well.
Надо сказать, что это был успешный запуск, и он символизирует о том, что все работы, дела обстоят хорошо в этом направлении.
And within a year from now, we will see 15 more launches to the International Space Station, providing assembly elements and resupply.
И начиная с этого дня у нас будут регулярные полеты на Международную космическую станцию, которые будут доставлять грузы и будут оснащать Международную космическую станцию.
And we are very pleased to also note that we will have our first experiments on board of the Russian service module and also see our first astronaut in April next year, Umberto Gondoni, on board of the International Space Station.
И мы очень рады, что будут проводиться работы на российском служебном модуле, и в следующем году мы тоже из ЕКО пошлем своего астронавта Гудони, который должен полететь на станцию в следующем году.
So we are very pleased with that partnership and look forward for good cooperation also in the future. Congratulations again and thank you.
Очень рады участию и сотрудничеству в этом проекте. Еще раз поздравляем всех с этим успехом. Прошу вопросы.
Go ahead and ask questions. Go ahead. I'd like to apologize.
Давайте мы сейчас выслушаем все вопросы, а потом часто выяснить
all the questions, general questions, and then you can take the specifics offline.
Заместитель генерального директора Европейского космического агентства господин Фёйстель-Бюхель.
Deputy General Director of the European Space Agency, Mr. Feuchtel-Büchel, beginning with an F. That's his last name. He's got a double last name. How many countries are involved in ESA, and what are the entry requirements for ESA?
We have actually 15 countries in the European Space Agency.
В Европейском космическом агентстве представлено 15 стран.
There was just number 15 coming recently with Portugal, so that's our youngest member.
Надо сказать, что цифра 15 была достигнута совсем недавно, и Португалия стала самым нашим молодым участником.
And we have already, in preparation of future members, we have some discussions with Eastern European countries like Poland and Hungary and Czechoslovakia and Romania.
И мы ожидаем, что количество будет увеличено. Сейчас ведутся разговоры с бывшими восточноевропейскими странами, с Польшей, Румынией, Венгрией.
These are first steps to enlarge our partnership, and ESA is in principle open for a wider participation. Of course, the participation so far was limited to European countries. As our name says, we are the European Space Agency, but we are nevertheless open to discuss also with other partners.
И надо сказать, что ЕКА открывает свои двери для участия всем странам, но, как видно из нашего названия Европейского космического агентства, мы в основном ведем дела с европейскими странами, но наши двери открыты, и мы готовы обсуждать вопросы, связанные с этой программой и сотрудничеством с другими странами. Пожалуйста.
Go ahead.
Агентство Интерфакс. Скажите, пожалуйста.
The Interfax Agency. You said that there is going to be an ESA astronaut next year. What is the crew? And the second question is about the European segment about on the International Space Station. When is that going to happen? What are the elements?
What the ESA segment looks like and what is the schedule for the build-up.
Our first astronaut, as I mentioned, will be Umberto Guidoni, an Italian, who will fly on board of STS-100, which is planned for end of April.
Надо сказать, что первым астронавтом будет астронавт Италии Умберто Гидони. Он полетит на шаттле полет СТС-100, который запланирован на апрель следующего года.
And this is related to the flight of the multi-purpose logistics module, which was developed by Italy. And one of the elements, Raffaello, is going to be launched at that occasion of STS-100.
Это будет связано с запуском элемента многофункционального блока, который называется Рафаэлло, который построен в Италии, и этот запуск будет как бы приурочен к запуску этого европейского сегмента.
With respect to your second question, I would like to say that we have two basic elements on board of the station. One is the Columbus laboratory, which will be launched in 2004.
Ну, если отвечая на вторую часть вашего вопроса, первый элемент Европейского космического агентства это будет лаборатория «Колумбус», которую мы планируем запустить в 2004 году.
And the other one is a transfer vehicle called ATV, Automatic Transfer Vehicle, which is sitting on top of Ariane 5. And in this context, we have a very close cooperation with the Russian Space Agency, Rosaviakosmos, and RKK Energia.
И следующий элемент это будет европейский космический корабль, который будет запускаться ракетой «Ариан». И надо сказать, что в этой программе у нас тесное сотрудничество и с российским космическим агентством, с российской корпорацией «Энергия».
Пожалуйста.
Go ahead.
Владимир Яценко.
Vladimir Yatsenko, Technologies magazine. In the course of Russian President Putin's trip to France, there is a planned meeting with the French cosmonauts, and I have a question for you. Do you have information on the agenda of the meeting, and is this meeting in any way related to the International Space Station program?
The Russian president is presently in Paris, as you correctly say, and today I think there will be a decoration of two astronauts, former French astronauts and now ESA astronauts, Claudie André Deshaies and Jean-Pierre Ignoret, who will receive a decoration out of the hands of your president. And of course that marks on the one side the intensive cooperation that Russia has with France on the one side and also with the European Space Agency on the other side. Both of them have flown on board of the Mir station. So I think that is a milestone also in our bilateral cooperation.
Вы абсолютно правы, когда заметили, что российский президент находится во Франции. Насколько я знаю, сегодня запланированная встреча с бывшими французскими мини-астронавтами ЕКА, и во время этой встречи будет церемония награждения двух французских астронавтов, которые летали на станцию «Мир». Это подчеркивает двусторонние связи между Францией и Россией в области освоения космоса и говорит о наших тесных взаимодействиях. Пожалуйста, еще вопрос.
Any further questions?
Новости.
Novosti, Russian news agency. Edward Puzerov, I wanted to congratulate
руководителей пресс-конференции, участников пресс-конференции.
The participants in this press conference, because your efforts
помогли
have borne fruit and have helped achieve this launch today.
А вопрос такой.
And the question that I had is like this.
Ближайшие после стыковки первые 3 дня
the first 3 days or the first week after docking, what are the crew members going to do? How successfully will they be able to operate on the Russian service module, which, according to the mass media, is loaded with all kinds of cargo that they will have to deal with? How are they going to spend their time? Do they all have their own locations for leisure and rest? Yuri Grigoriev is going to answer. We understand the question. There was information that the FGB and the service module are loaded. Both the recent orbiter crews were engaged in unloading some of the cargo and installing some of the equipment, the treadmill and so on. The crew has been in training for a long time, and they have been running into one another, as it were, for a long time. They're all very experienced crew members. Bill Shepard is an experienced astronaut. Sergei Krikalev is close to record, and in the first week after their ingress, in addition to the various medical procedures while they're adapting to space, they're going to activate the station, they are going to activate the life support systems, and they're going to test out the various station control systems to understand maneuverability issues. As far as the load is concerned, the station is not too overloaded with cargoes based on the information from the previous crew, and I think that we'll get confirmation the day after tomorrow that it's not uninhabitable. There will be some components that will have to be stowed on board the station, but there are measures to use the space behind the various panels, both on the service module and the FGB. This is not as serious as it might have been. Okay, any new questions? A question for both NASA Energia and ESA. What did the crew members take aboard the Sojuz in the way of equipment, in the way of personal possessions? And what joint hardware is already on board the station that might have been brought aboard the orbit?
Okay, well, obviously there's a lot of items that were stored on the Soyuz.
Ну, конечно, можно сказать, что много чего было загружено в Союзе.
Including all the meals that the crew selected.
Ну, включая то питание, которое отобрали члены экипажа.
Clothing and personal effects.
Одежда и личные вещи.
And one of the major items was the flight data file that they will use to operate equipment and set up equipment during their stay.
Ну и, конечно, то оборудование, та документация, которой они будут пользоваться во время эксплуатации того оборудования, которое находится на станции.
A majority of the equipment that they'll be using, life support equipment, is already in place on board, was brought up by previous shuttle flights.
Ну, то, что касается системы обеспечения жизнедеятельности, это оборудование уже было доставлено шаттлом, и оно находится уже на станции.
Go ahead.
Еще вопрос.
Are there any other questions?
Если вопросы... пожалуйста.
Oh, go ahead, please.
Микрофон у вас рядом.
You have the mic next to you. Why don't you use that?
У меня вот оба вопроса. Предыдущий ваш вопрос хотел бы тоже комментировать.
I also wanted to comment on your previous question, the acoustic issue.
Начало длительных пилотируемых полетов является...
This has been a major issue throughout manned flight, a philosophical issue. There are standards on the one hand that are been put together by medical people around the world, including Russian medical specialists. There's also lengthy practical experience over many years of ongoing flight, manned flights, showing that this is viable. Yes, there is a certain amount of discomfort. The primary source of noise are the propulsion units, fans, that are of some concern. We're working with these issues, though, at least in Russia and the United States, and have been working on these issues for a long period of time. We have a tremendous range of experience here, and a number of efforts, long-term efforts are underway, which are being implemented, but we're moving towards resolving this issue, although the medical people want us to totally take care of this, to have no more noise at all, which doesn't happen. We have about 50 decibels, and in places 58, 60 decibels on the FGB. The service module under ground measurements, the treadmills, U.S. treadmills primary source, up to 50-something decibels. We are working to overcome these issues and have been working on them for a number of years. I think within the next year or two, we should have a normal noise environment. Russian cosmonaut doctor spent 50-60 days up there. Although the Mir had a very noisy environment, it was fine. Of course, it's a enclosed environment where people people or working or living. There are certain strains of microorganisms that do occur there. They can be in the different hardware on the station, and this is another issue of focus with medical people, microbiologists. Yes, there was a rumor that in different bags provided by the U.S. to the FGB, after a year and a half or so of being in space, there were certain colonies of fungus or mold. Although initially we took care of this, the last shuttle crew that ingressed 2 weeks ago did a full disinfection of all the equipment. So this is an issue that we need to track. Okay? A close environment, the atmosphere needs to be healthy, and this is a subject of ongoing focus of the medical people, the MCC people, and the crew itself, because this is, first of all, has to do with crew health. I hope I've answered your question. If you have any others, go ahead. So the problem does exist. We can address it. It needs ongoing monitoring to be followed by the crew, the astronauts, the cosmonauts, the medical people who work with the crew, and the flight control people in order to take the preventative measures to ensure that the station is microbiologically clean and suitable for the health of the crew. If there's no other questions, thank you. We would invite you to assist at the docking on the 2nd of November, where we have set up all conditions for the press, written press, and television people will come here. We'll have 2 people at most from each company, 3 at the most from each company. It'll be a good environment for you to work in. Thank you for your attention, and I wish you all the best.
Как меня слышите? Я вас замечательно. 46-й. 46.
48, 46. How do you read?
This is Mission Control Houston on board the Sojuz spacecraft, currently out of communications range with Russian ground sites. The crew should be moving back within communications range with the Russian ground site, allowing more air-to-ground conversations between the crew and Russian controllers at Mission Control Center in Korolev, moving in range in about 16 and a half minutes or so. The Sojuz
checking complete.
Is in an orbit with a high point of 248 kilometers, a low point of 190 kilometers, or about 154 statute miles by 118 statute miles. An average altitude of about 136 statute miles for the spacecraft. Coming up are 2 engine firings. That first engine firing will be coming up at about 5:27 a.m. Central Time, resulting in a change in velocity for the spacecraft of about 44.6 miles per hour. That engine firing, the first of 2 that will raise its orbit up more closely to the 240 statute mile orbit of the International Space Station, among the series of engine firings over the next couple of days that will draw it to rendezvous and dock with the station. The second engine firing is planned at 6:09 a.m. Central Time this morning. That engine firing will change the velocity of the spacecraft by about 32.5 miles per hour. At the end of both of those engine firings, the Soyuz is planned to be in an orbit with an average altitude of about 160 statute miles, actually a slightly elliptical orbit with a high point of 168 statute miles and a low point of 152 statute miles. Again, next, however, in about 15 minutes, the Soyuz will be moving into range of the Russian ground sites, and we anticipate more communications with the crew. During this first orbit of the Earth, the crew will be ingressing the orbital module of the Soyuz, deploying the docking probe, performing a checkout of the Soyuz motion control system, and include a checkout of the hand controllers, the rotational hand controller and translational hand controller in the spacecraft, and taking off their suits worn during launch.